Whenever math comes up, everyone is always like, when am I ever going to use this in real life? How about right now? Strap in and I'll learn you some math in the context of Payday. We're going to start simple and then get more complicated, so let's jump in. Operations. When I said starting simple, I really meant it. Based on my interactions with public players and a decent amount of the community, elementary school math seems like a good starting point. Alright, so addition. You've got one zeal heavy and you add another, and you have two zeal heavies. For subtraction, you've got 230 health in your health bar and get shot by a 225 zeal shot, and now you've got 5 health left. With subtraction, you can also go negative, like how ICTV gives negative 55 dodge, which means using rogue for 45 dodge will leave you with negative 10 dodge. This doesn't actually magnetize bullets to you or anything, since it's just the same as 0 dodge in terms of Payday, but negative numbers are just in the other direction of the number line. Multiplication. The KSP LMG deals 80 damage per bullet and has 200 bullets in a magazine, which means spending the entire magazine will deal 16,000 damage, which you get by adding 80 200 times, or 280 times. Division. The Cobus shoots 909 bullets per minute, and there are 60 seconds in a minute, so it shoots 15.15 bullets per second. If you don't understand these operations, I'm sorry, there is no hope for you. Let's increase the complexity just a smidge and talk about the order of these operations, which can be remembered with the acronym PEMDAS, or BEDMAS in less relevant parts of the world. This stands for parentheses, exponents, multiplication, division, addition, and subtraction. Now let's get a quick point out of the way. This isn't a strict rule because division and multiplication are interchangeable, and addition and subtraction are interchangeable. Whenever you see stuff like this online asking for an answer, it's just interaction bait. These problems are designed to be ambiguous so that any answer you get is correct. No one ever writes anything like this when they're trying to be useful, and it's why parentheses exist. For example, if you have Maniac and Frenzy, Frenzy applies first and Maniac applies second. But if you have an Yzma with Buckshot and the skill Shotgun Impact, there exist parentheses so you add Buckshot first, and then Shotgun Impact second. So that covers P, M, D, A, and S, but not E. Exponents are repeated multiplication, or repeated division, because like I said, multiplication and division are the same. Critical hits apply the headshot multiplier again, so if you headshot an enemy and happen to crit, that means you do the multiplier, and then do it again. If you do repeated division instead of multiplication, the exponent goes negative, which is just the equivalent to 1 over the number of the positive exponent. Whoa, hold on, new challenger. This form is a fraction, and really just means division. The top number is divided by the bottom number. You can also think about fractions as ratios, like the fraction of Payday 2 to Payday 3 players is about 30. Which means there are about 30 Payday 2 players for every single Payday 3 player. You may notice that the division symbol kind of implies this form, which is neat. You can also convert fractions to decimal form, which in itself is the common way we do numbers. It means that you count from 0 to 9, and when you reach 10, you just start a new number. Other systems you may have heard of are binary, which is used by computers and goes up to 2 before starting a new number, and hexadecimal, which is used by computers for convenient storage and goes up to 16 before starting a new number. These bases extend to whatever number you want, but 10 is the standard. You can also write every number as a sum of the base to an exponent. For example, Akimbo Krinkovs with Akimbo and fully loaded have 338 ammo. The 300 can be represented with 3 tens to the power of 2, 30 can be represented with 3 tens to the power of 1, and 8 can be represented with 8 tens to the power of 0. This is essentially where scientific notation comes in, which is used to show numbers that are either really big or really small. If you've ever wondered how much money I actually have in my offshore, this E is generally used to represent 10 to the power of whatever comes next. So 3.08926 times 10 to the 15th power, which is about this much. Almost enough to afford 2 college textbooks. Back on the topic of fractions, sometimes converting fractions to decimal will give you a number that cuts off, and sometimes it won't, and you get repeating decimals forever. Since each successive spot to the right is less and less useful, you usually just cut it off wherever it feels right and round the rest, unless you specifically have to use a certain number of digits. So with that in mind, you can see how decimals connect to fractions by using multiplication or division. However, decimals can also be used to represent percentages, which literally mean per hundred. Fractions also do this, but you generally simplify fractions, so decimals are nicer. So many skills in Payday 2 refer to percentages that I don't really even need to bring up an example for you to know what I mean. But I still will. Helmet popping from the second card of every perk deck is a 25% boost to headshot damage, which means that you multiply damage by 1.25. With 1 representing the current damage, and the 0.25 representing the additional part. Lastly, I want to cover dimensional analysis, which is not quite an elementary school topic, as you may have guessed from it being called dimensional analysis, but it fits well in here and also really isn't that complicated. When it comes to practical math, there are almost always units with numbers, and they somewhat decide rules for what operations you can do. For example, you can add 1 heavy zeal plus 1 heavy zeal to get 2 heavy zeals. But if you were to add, say, 1 heavy zeal and 1 ammo bag, well, what do you end up with? 2 heavy zeals? Clearly not. 2 ammo bags? No. 2 heavy zeal ammo bags? What even is a heavy zeal ammo bag? This problem does not apply to multiplication. For example, damage per second. What does it mean? Well, you take damage and you divide it by seconds, and you get damage per second. And if you know that you do 300 damage per second, you can multiply by 5 seconds, and the units combine, and you get 1500 damage. For such a fancy name, it really isn't anything amazing, but it can be useful. And that just about covers the basics, so let's move on from elementary school math to middle school math. Ladies and gentlemen, algebra. Algebra uses the operations from elementary school to make functions. Functions take an input and give an output. Now let's clarify some things about functions. A function has to have only one output for every input. Otherwise, you wouldn't be able to get a whole lot of use out of the function. You can have multiple inputs that lead to the same output, though. Next, functions have to have a domain and a range, which is to say a limitation for the input and a limitation for the output. Your domain and range are expressed using this coordinate-esque format, where the first number is where to start and the second is where to end. If you have a parenthesis, it means that the number isn't included, and if you have a bracket, it means that it is. If you see a U, it means that there's a break. More often than not in basic algebra, your domain is going to be from negative infinity to positive infinity, with maybe some unions in between. Or in other words, you can put basically whatever you want into the function. This isn't necessarily true for the range, which is the more interesting part of the function anyway. In Payday, there are a lot of things that you can use functions for, so let's take a nice and simple example to do with experience gain, E. Big Bank will give you XP for various things. 8,000 for hacking, 4,000 for the time lock, 10,000 for activating the escape, and 8,000 for finishing. All of this fluff can be combined into one big thing of 30,000 XP. You also get 1,000 extra per bag, B, secured, and finally you have the death sentence experience multiplier. Now you can see pretty clearly how experience is a function of bags secured, but you can also go in the other way with an inverse function, which is to say that knowing how much experience you got, you can find how many bags were secured. If you want it to be real and true, you'd swap the variables and solve in the other direction, as what I'm going to do here is technically just a whole different function that happens to look like the inverse, but uses a different variable. It's not that important. Anyway, the point is that with algebra, whatever we do to one side, we also do to the other. So now we divide out the DS multiplier, then subtract the fluff, and then divide by the experience per bag. Now, for any experience you plug into here, you can figure out how many bags are secured during that run. At least in theory. You can't have half a bag, and that's what setting specific domains and ranges does. Say you wanted to know how many headshots it will take you to kill a death sentence minigun dozer. The input here we call D for damage, and the output S for shots. Death sentence minigun dozers have 48,000 health, and a 7.5 times multiplier, as well as that 1.25 times helmet popping buff. This means that a headshot will do 9.375 times the damage you have. So the amount of shots S you need to kill the dozer is 48,000 divided by 9.375D. Lastly, we just need to set a restriction on the domain, and the damage can't be negative or zero, since neither of those will make sense in context. Negative damage would heal the dozer, and zero damage means you'll never kill him, but anything outside of that works. So the domain in this case will be from 0, not included, to infinity, which is always not included since it's not a number. More on that later. And there we go. A function. Put in whatever damage you want, and you can find out how many shots it will take to kill the dozer. Now, I said that 0 isn't included because it wouldn't make sense, but there is a general math issue to be wary of here, being division by 0. Since I mentioned earlier multiplication is repeated addition, division is repeated subtraction. We can look at our function. Say we have a Thanatos that does 3,500 damage. Multiply it by 9.375, and we get 32,812.5. So we subtract this from 48,000 and get a positive number, so the dozer is still alive. Subtract once more, and the number is negative, meaning the dozer is now dead. Now we swap out the Thanatos for an imaginary gun that does 0 damage. Multiplying anything by 0 makes it 0, so now all that's left is repeated subtraction. 48,000 minus 0, and we get 48,000. Minus 0 is 48,000. Minus 0 is 48,000. Minus 0 is 48,000. Minus 0 is... This isn't getting anywhere. You may be tempted to say infinity here, but again, infinity isn't a number. More on that later. Basically, division by 0 is broken in many different ways, and there are tons of explanations as to why, but that one is my personal favorite. We can also confirm that this function makes sense in another way, which is the dimensional analysis I mentioned earlier. You have the kill damage divided by damage per shot, and you get kill shots, which is exactly what we're looking for. Now, this is good and all, but what if your function depends on multiple factors? Imagine we want to find sustained damage per second of a weapon. To get your output, you would need the damage and rate of fire to get the DPS, and then to find the sustained DPS, you would need to use the reload time and magazine spend time, which leaves you with 4 variables. Well, all we need to do is define a function dependent on 4 variables. Back when I was in algebra, I'd always wonder what the point of using f of x instead of y was, because they meant the same thing. That's true, but if you ever have a function relying on multiple variables, it's nice to know exactly what affects your output. In this case, d damage, r rate of fire, m magazine size, and t time to reload. To make this function easier to digest, let's break it into its components, being DPS divided by the time. DPS is easy. The D in DPS is conveniently for damage, which is already the D we're using. Now the PS is per second, which we can pull from fire rate. Rate of fire is initially shown in bullets per minute, and if we want bullets per second, we need to multiply by 1 minute per 60 seconds. And there we go, bullets per second. So our DPS is DR divided by 60. For the second part, we want the total cycle time to spend the magazine and reload the gun, which means we add T to the time it takes to spend the magazine. You have M bullets and you shoot R divided by 60 bullets per second, so 60M divided by R gives you seconds. And now we have both parts, the DPS and the cycle time. Divide the DPS by the cycle time, and there we go, our function. Again, set all the domains, and done. There you have it, algebra. As long as you break down every part carefully and follow the logic to reach what you want, it's simple. And that's really the point of math, to use logic to combine simple concepts and get practical information. Now, that's not necessarily always true. I don't think I can convince you that inter-universal take-Mueller theory is useful to everyday life, but hopefully you can see how the math you learn in elementary and middle school can be applied to real situations, even if I'm doing that through the context of a game. We'll get to the high school and college level later, but for now let's just get into the next middle school topic, which is geometry. Geometry, put simply, is just the study of shapes. Let's talk about circles first. Circles are easy enough to digest. You've got yourself a center point and a distance, and a circle is just tracing the distance around that point. A skill like Underdog Basic, for example, uses a distance of 18 meters and yourself as the center point. This means enemies within that area can activate Underdog. But what even is this area? First, you can think about a line. It has a length. Now, if you connect 2 lines together, you can make a square, and they have an area. Connect that square to another square, and you get a cube, which has a volume. Connect 2 cubes together to get a tesseract, and you have... Well, mathematicians kind of get lazy at this point, and everything in 4 dimensions and past that is usually a 4D volume, 5D volume, etc. Anyway, back to our circle. The area of a circle is pi r squared, with r being the distance from the center and squared giving the area. Pi is just a constant, meaning it's a number that doesn't change, and as for where it comes from, that's above the scope of this video, and I also wouldn't have a Payday example, so just accept it as 3.1415. You'll never need more accuracy than 5 digits. So we've got an underdog circle, but what about the enemies above and below you? Naturally, you'd think that you get a sphere, but this is Payday math, and it's actually not for whatever reason. You may have a horizontal circle with an 18-meter radius, but vertically, it's 10 meters. In 3 dimensions, this would give you an ellipsoid, with a volume of 4/3 pi times the distances. In this case, 18, 18, and 10. And hey, if all the distances are the same, what do you know, a sphere. Why 4/3? Just like with pi, I can only really ask you to accept this as a fact. If you are interested, feel free to look it up, but I will warn you there will be no Payday in those videos. Anyway, we've concluded that Underdog has an active volume of about 13,500 meters cubed. Here's a question. How inaccurate is a gun after a certain distance? The long guide tells us that the spread in degrees is given by 2 times 1 minus the accuracy over 100. But what's a degree? And how can we even use that to find out our inaccuracy at a range? If you take a circle and split it into 360 even slices using the radius, the angle between the sides of the slices is 1 degree. Why 360? Simply put, it's just a convenient number. 360 is what's called a highly composite number, or sometimes anti-prime. 360 has 24 factors, which is a lot, and that means you can get many clean and easy slices. If you want 4 slices, each one will be 90 degrees. If you want 30 slices, each one will be 12 degrees, and so on. Anyway, back to our accuracy. So, if we have the spread angle from this equation, we can make a triangle of the distance an enemy is at and how far the bullet could deviate. Let's compare 82 accuracy, which is 0.36 degrees, and 90 accuracy, which is 0.2 degrees, at a range of, say, 40 meters, as is required for the far, far away achievement. We've got a triangle, but what is this distance? For an isosceles triangle, which is to say a triangle with two equal length sides, this distance is 2d tan theta over 2. What the hell does any of that mean? Let's quickly go off to the side and start with right triangles, which is to say a triangle that has a 90-degree angle on one of its corners. These triangles have sides that follow the well-known Pythagorean theorem, which uses the two side lengths A and B to find the hypotenuse C through this relationship. That was the easy part. The more complicated one is the tan. Sine, cosine, and tangent are trigonometric functions which can relate the angles and sides of right triangles. Their values specifically relate to the coordinates of a triangle inscribed in a circle of radius 1. What do these coordinates and circles have to do with triangles? Bam, triangle. This circle is called the unit circle, and using the lengths of the sides, you can find the angles of the triangles, or using the angle and hypotenuse, which is always 1, you can find the sides. Using these relationships, you can solve for any side for any angle. So, if we want the base of this triangle, we can start by splitting it in two to create two equal right triangles. This also cuts the angle theta and deviation distance x in half, and since we know d, we can use the tangent function. From that, we get that tan half theta is equal to half x divided by d. Since we are solving for x, just multiply the d to the other side, and then multiply by 2 to get back to x. And there you go, 2d tan theta over 2. Now we can plug in 40 for our d, since that's the range we want to hit enemies from, and plug in theta for our different accuracies. For 82 accuracy, we can find that the deviation is about 0.25 meters, and for 90 accuracy, we can find that the deviation is about 0.14 meters. These seem very similar, but the head hitbox in Payday 2 is 20.15 centimeters, or about 0.2 meters. If you place this head hitbox and overlay the different deviations, you can see what a difference 82 versus 90 accuracy is. Remember, this is if you're aiming exactly in the middle of the head, and these spaces are you missing simply due to RNG. Congrats on passing geometry. It's time to get into high school material. Let's start with something relatively simple, combinatorics. It may sound spooky scary, but here's what combinatorics is about. Payday the Heist has 4 characters: Dallas, Hoxton, Wolf, and Chains. How many combinations of characters can you have in a team? Well, 1. Dallas, Hoxton, Wolf, and Chains. Here's another question. How many permutations of characters can you have? Well, you have Dallas, Hoxton, Wolf, and Chains, Dallas, Hoxton, Chains, and Wolf, Dallas, Chains, Wolf, and Hoxton, Dallas... On second thought, this is too much work. We can mathematically represent this team creation to speed this up. How many choices do we have for the first character? Well, all 4. How many choices do we have for the second character? All the characters except the first one, so 3. How many choices do we have for the third? Well, 4 characters excluding the first and second, so 2. And the last character? Well, you can only have that one leftover character. If we multiply these together, 4 times 3 times 2 times 1 gives 24, and if you were to go through the work, you'd find there are in fact 24 ways to arrange these characters in a team. When you multiply successive numbers like this, it can be shortened to this symbol, representing a factorial. Factorial 4 means that you start at 1, then multiply by 2, then by 3, and then by 4. Factorial 5 is the same, but at the end you multiply by 5. Simple enough, right? Well, let's complicate this a bit by moving to Payday 2. How many possible permutations of teams are there in Payday 2? You still have 4 slots, but now there are 22 characters you can put in each slot. The first slot has 22 choices, the next has 21, the next has 20, and the last has 19. Multiply these together and you get 175,560 possible permutations. Of course, there is a mathematical way to represent this, and we can reason our way to it. If we have 22 characters, permuting them all gives an enormous 22 factorial, or about 1.12 sextillion. Yes, I said sex, we're in high school now, get over it. However, we are only picking 4, so how exactly do we clear out the rest of these numbers in the factorial? Since the factorial starts at 1 and goes up to whatever number you want, we can very conveniently just divide out the numbers we don't need with a smaller factorial. If we only want 4, we can then divide by 18 factorial, and there we go, our 175,000 number. We can generalize this into the permutation formula, with n options and r slots. But I mean, really, like with the Payday the Heist team, although there are 24 different ways to stick them together, it's still the same team. So how many possible unique teams are there in Payday 2? Well, you can logically see that whatever permutation team we pick, there are 4 factorial ways to arrange them. Think back to when I wrote out all the ways you can combine the 4 OGs. We can simply divide that out as well, and we arrived at the combination equation, which again only relies on how many options there are and how many slots there are. Using this equation, or just dividing our 175k by 24, we get the actual number of different teams in Payday 2, 7,315. Combinatorics by itself is kinda whatever, but it's used in probability, our next topic. Let's start super basic, with just the odds of dying on rogue immediately to heavies, which involves getting hit 3 times, once for armor and twice for health. Base suit rogue gives you 50 dodge, which means your chance to get hit is 50%, or 0.5 in decimal form. Getting shot 3 times just means multiplying these together, or 0.5 times 0.5 times 0.5, which equals 0.125, or a 12.5% chance to just die. Now you get your hands on Sneaky Bastard, which means you have 60 dodge, or that you get hit 40% of the time. To die instantly in this case, you just multiply 0.4 times 0.4 times 0.4, which equals a 6.4 chance to die immediately. But hey, let's suppose you don't have atrocious luck and your armor breaks. You dodge a bullet, and then get bullseye, and then get hit twice and live. In this case, the chance to get hit is 0.4 times the chance to dodge, 0.6, times the chance to get hit twice, 0.4 times 0.4, which equals 0.0384, or a 3.84% chance. So is it rare to get shot 3 times and dodge once than it is to get shot 3 times? Well, yes and no. In the case of 4 shots, there are 16 ways they can play out, but there are 4 different ways to get hit 3 times and dodge once. It's just that each particular one of those has a 3.84% chance of happening, altogether being 15.36, or about twice as likely compared to getting hit 3 times by 3 bullets. We'll come back to dodge later on, but let's say you're the Dallas #1 fan and want to always have him no matter what lobby you join. Assuming all characters are picked equally, what is the probability that you can join into a lobby that already has 3 players and get to play Dallas? This question is actually simple enough, really. All you need to do is find out how many 3-person teams there are, and how many 3-person teams with Dallas there are, and then just subtract those out. Using the combination formula, we can find the amount of teams simply with n equals 22 and r equals 3, giving 1,540 teams. The amount of teams without Dallas would be the exact same, but with n equals 21, for hopefully obvious reasons. This calculation gives us 1,330. Subtract the teams without Dallas in them, and you'll find there are 210 teams with Dallas already in them, meaning about 13.6% of lobbies will have you not playing Dallas. So the probability of joining a game with 3 players and getting to play your beloved Dallas is 100% minus 13.6%, which is equal to 86.4%. Not bad odds, at least in this fantasy land where everyone is picked equally. Alright, it's time for the big scary boy, calculus. But first, let's talk about movement speed. Watch this clip here.
Here, reporting in. All is clear.
Did you skip forward? Congrats, you failed the attention span test. Now go delete TikTok and read a book. Anyway, we covered this distance of 100 meters in 22.1 seconds, so the speed is, quite trivially, about 4.6 meters per second. Now let's do the same thing while sprinting. Now we covered a distance of 16.4 seconds, meaning the move speed is now about 0.6 meters per second. Alright, one last example. The Longfellow covered this distance in about 8.8 seconds, meaning it has the highest movement speed of 11.4 meters per second. Oh, except, well, this. The speedometer on the car is saying that, in fact, the speed was changing throughout the entire drive. Let's take a step back. How do we find movement speed? We can graph the running test with the position on the y-axis and the time on the x-axis. From this data, we can pull out this equation. The slope, which is to say the change in y divided by the change in x, is the speed. You can tell that the slope is the same all the way through, so we can just calculate at any point to get that the slope is 4.6, which checks out. In a linear equation, this part is the slope. Now, if we graph the car position over time, you can clearly see that there's a curve present, which means that the slope is changing. The equation for this graph is this, which you can see isn't quite perfect since I rounded while finding it, but it fits pretty well. In a quadratic equation, it's not obvious what the slope is like in a linear equation, so we're just going to have to leave this for now. What was I even talking about before? Calculus? Right. Calculus, in simple words, is just about breaking things into infinitely small pieces, or adding up infinitely small pieces. But as I mentioned before, infinity isn't a number, so how is this possible? Well, you have to use a limit, and a limit is essentially what the solution will trend toward over time. From the minigun dozer killing example a long time ago, the limit as d goes to 0 is infinity. Well, technically there is no limit because the function is approaching different infinities depending on which side you come from, but since we're really only considering the positive damage numbers here, the limit is infinity. Using this idea of a limit, we can get to the first big topic of calculus, the derivative. I mentioned that the slope is the difference in y over the difference in x, and in the car graph, you can progressively take the slope of smaller chunks to be more and more accurate. We can call these smaller chunks z. The denominator is very simple. We choose an x, and then add z to it, and then subtract x. Whoop-de-doo, we just get z back. The numerator depends on the function, and if we go back to our car equation, like with the denominator, we just plug in x plus z for the first section, and just x for the second section. We do some algebra here, and done. There's our slope. Like expected, it's not just a constant number, meaning that the slope is changing, and we can plug in for any time x to find the speed at that time. Alright, whatever, I'll cut to the chase. There are two common ways of writing derivatives, the first of which is f prime, f double prime, f triple prime, etc., which is saying the primeth derivative of a function. The second is dy dx, d squared y over dx squared, d third y over dx third, etc., which is saying the small chunks of y divided by the small chunks of x, aka the slope at smaller and smaller intervals. The idea of smaller and smaller chunks beckons a question. Is there a smallest chunk? As your resident physicist, the answer is yes. The infinitesimal does in fact exist, and the dy dx format can be treated as a fraction and multiplied out as such. Don't fall for the mathematician's propaganda that there is no infinitesimal and dy dx is not a fraction, even though it totally can be treated as such with basically no issues. Anyway, when it comes to derivatives, there's a couple rules you have to remember. If you remember these rules, you can pretty easily take the derivative of any function, with the caveat that it has to be continuous and differentiable. Continuous just means that it doesn't break at any point, or that every x you put in will actually give you a y. Differentiable just means there can't be any quote-unquote sharp points in the graph. Even though these are the rules of differentiation, they're really more suggestions than anything else. 1 over x is not continuous because it breaks at 0, but you can still take the derivative of it. The delta function used in physics is in itself a derivative of the theta function, which is a so-called sharp function, and even then, you can go for the nuclear option and just make a piecewise function, which is a weird way to combine functions. The absolute value function, for example, is just the positive value of x, which means that it comes to this sharp point at the base. Just call it two different functions and done. Now, the second part of calculus is the integral. If derivation is breaking a function into small pieces, integration is putting those pieces back together. Stay with me here, but imagine that you want the area under a curve. Well, the simplest guesstimate you can make is to just draw some rectangles since they have an easy area. The height is, well, whatever value this is, and the width is whatever you want. Obviously, this is not very accurate, but if you make the width smaller, they become more accurate. So if you just make the width the so-called infinitesimal, you're going to be perfectly accurate. As for the height, it's still just whatever the value of this function is. So height times width is just the function times the infinitesimal. This is just a cool sum, but it's not an integral. An integral is when you do this sum, but you have this funky looking s in the front. This s is telling you to differentiate the function inside backwards, and the infinitesimal at the end tells you which variable you're anti-differentiating with respect to. It's easy, you know the rules, just do them backwards, right? Well, as it turns out, integrating is much harder than differentiating, and you can see why maybe with this example here. It doesn't look all that complicated. Integrating x is just half x squared, and integrating sine is just negative cosine, and so the derivative is negative half x squared cosine. Except that's not right. Because of the chain rule causing issues, there are tons and tons of different tricks and techniques for figuring out antiderivatives, which is why they teach classes on this stuff. I'll only be showing you a simpler integral here, so no real point covering techniques. Let's take the derivative of our car example as a function. It's easy enough to integrate, and also, well, we know what the result is. However, with integrals, remember to always add a plus c at the end. This c is just a constant, which is to say a simple boring number. Whenever you differentiate a straight up number, it disappears, so the derivative of all of these functions is the same, and this plus c is here to cover them up. This is an indefinite integral, but there is also a definite integral, which has these two bounds. Everything is the exact same here, but instead of this plus c, you just plug in the top number and subtract plugging in the bottom number, and hey, callback! This gives the area of this function from the bottom number to the top number. With our car example, integrating from 0 to 8.8 seconds gives 100. I mean, it doesn't, because the original function wasn't perfectly accurate, but it would give 100 if it was. Now, supposing this is a perfectly accurate function, how much further would the car have gone if it drove for 10 seconds instead of 8.8? All we need to do is integrate the function with bounds from 8.8 to 10, and you can see that in that extra second and a bit, the car would have gone another 23.4 meters. With that, I think it's time to move on to college material. There is another, weirder field of calculus called differential equations. It may sound intimidating, but really it's just regular algebra, except that the equations can have derivatives inside of them. This is a weird idea, so it's best to give an example. What rate do you shoot bullets at? And I don't mean the rate of fire, I mean in general. If I have a microgun, for example, when I have full ammo, I spray that bitch indiscriminately. While I do that, the ammo count goes down, and I slow down a bit. Can't be busting my load super fast and run dry for the rest of the heist, right? And if my teammates keep gobbling up the ammo I make, eventually I reach the dire straits and swap to my secondary to refuel the primary. Essentially, if we call the amount of bullets in my gun A, the rate of change of my ammo count is dA dt equals negative GA over 750. Hopefully the derivative here makes sense. It's the rate of change of my ammo count. 750 is the total ammo of the microgun, and G is just a constant that we can technically get by experimenting and getting data to compare to, but we could just leave it for now. If my ammo is full, then my ammo count goes down by negative G. If my ammo is empty, then the rate of change of my ammo is, well, 0. I don't have any ammo to spend. This is as basic as a differential equation gets, and because of that, you can solve it by separating the variables and just integrating. Remember to add the constants, and then you can combine them to one side, and there you go, the equation for the total amount of ammo I have over the course of a heist. I skipped over logarithms earlier because it didn't really fit in anywhere, but logarithms are essentially the opposite of exponents, where log base 2 of 8 equals 3, because 2 to the third power is 8. ln is the specific logarithm that uses Euler's constant as the base, which is another one of those funky numbers like pi. It's about 2.718, and I won't be explaining where it comes from either. Anyway, you can see how the ammo just kinda goes to 0 over time. Since the equation is only considering that I'm spending ammo, that checks out. Let's go back to our equation and add another constant, h, representing how much ammo I pick up, and multiply it by t to represent that it's not just a one-time pickup, but that it's something we keep picking up over time. This kind of equation can't be separated, but we can use an integrating factor. I'm going to gloss over the math here, and there, our function. Of course, the function depends on time, but also on three constants, g, which we can call the natural spending rate, h, the ammo pickup, and of course the integration constant. Let's just say you pick up one box every 2 seconds, making the h 11.39 on average for the microgun, and we can solve for the integration constant by plugging in initial conditions. Over time, you see that the ammo isn't just going to 0. Differential equations are very diverse. Sometimes the field is jokingly compared to zoology, since a big part is describing what kind of equation it is to figure out how to solve it. For example, the first ammo equation I gave is an ordinary linear first-order homogeneous differential equation, and the second was an ordinary linear first-order heterogeneous differential equation, which is why they can't be solved the same way. Alright, let's get to statistics. Probability is so nice and everything works fine, but the real world works on a higher level called stats. Statistics has a million different ways to compare theoretical data to real data, and they all have their own uses, but I'm going to give you probably the most well-known distribution, the binomial distribution. In the case where you have something with a chance to happen and not happen, you can put together this equation that looks scarier than it is. This part over here should be familiar, it's just the combination formula. These two parts are just the chances of something to happen and not happen. You can take a specific case here, and then multiply it by the amount of different ways it can happen. Let's just get an example going. Since we're talking about stats, it's only fitting to talk about dodge. Suppose you're playing Suit Express with Sneaky Bastard, and for the benefit of the doubt, let's just give you 10 more dodge from always sprinting, resulting in 40 total dodge. What are the odds of dodging, say, a 34 out of 40 bullets? Well, we plug and chug these numbers, and we end up with a probability of 5.3 times 10 to the negative 7% chance. Well, I mean, it's unlikely, but who's to say if this is legit or not, you know? Well, let's just compare it to a normal distribution. The average of the binomial distribution is 40 times 0.4, which equals 16, and the standard deviation is the square root of 40 times 0.4 times 0.6, which is 3.1. The average makes sense. You have the amount of bullets times the dodge chance, and there you go, the amount of times you expect to dodge. The standard deviation, well, what even is a standard deviation? The standard deviation is a sort of average away from the average, but technically it's the square root of the variance, which is the average away from the average. But like a few other things in this video, I'm going to ask you to just accept this as a fact, because I won't derive it for you. Alright, so what's the normal distribution? This is the basic expectation you have for statistics, with the middle point being the average. Data is plus or minus one standard deviation away from the average about 68% of the time, and within plus or minus 2 standard deviations about 95% of the time. I don't really have the other standard deviations off the top of my head, because being outside of this 95% is usually the point where something has gone wrong with your data. Depending on the field, accepted p-values may be lower or higher, but we'll just use 0.05 here, or 5%. So our average is 16 with a standard deviation of 3.1, which means 34 dodges is a mere 5.81 standard deviations away from the average, which means something is definitely wrong with the data. And to tell you just how wrong it is, standard deviation tables don't even go this high, just because of how atrocious this result is. In simple results, this scenario would without a doubt be cheated dodge. Not that it matters, because I made up this scenario anyway, and no one would ever be stupid enough to try and pass that off as legit. Now, suppose we want to compare a set of data instead of just one result. Another test you can try is the chi-square test. The basis of chi-squared is the sum from taking your data point, subtracting what you expect to get, square it, and then divide by what you expected. I didn't cover this symbol, but it's the symbol for summation. It's sort of like an integral but for discrete points rather than the whole function. You may be thinking, couldn't you also just use this for one data point? Not really, because the chi-square test has degrees of freedom, which is one less than how many checks you're doing. And if you have 0 degrees of freedom, well, the chi-square test is just not the right test to use. Anyway, I asked some of my Discord members to run a dodge counter with different builds, and they delivered me some data. As you can see, there are 3 categories here: Suit Rogue for a straight 50 dodge, Suit Burglar for 35%, and Sneaky Bastard Suit Muscle for 15%. I didn't actually ask for this last category, but hey, why not? Here are the raw dodge counts for each of these categories, which are the observed values. Expected values, well, just multiply the dodge percentage by the total shots. Plug each into the formula, and we end with our chi-square value of 18.5. Since there are 23 data points, the degrees of freedom is 22, and checking in a lookup table, you can see that to get 18.2, you're going to fall somewhere between 0.9 and 0.1. Since we are using 0.05 to determine if something is wrong, we can see that even though some people who sent me their data got really lucky and some got really unlucky, the data is legitimate and doesn't scream that it's cheated or anything. If the chi-square value was something like 40, then it would mean that there's a 1% chance that our data was as it was because of sheer chance, or in other words, a 99% chance that something fishy is afoot. Let's get off of statistics because it's a bad field anyway, and move on to linear algebra. Linear algebra is probably the most important field of math for people who don't care about practical math. That may sound like an insult, but I swear it isn't. Although linear algebra is not very helpful to the average person, it's in everything from engineering to AI, and it literally only has one equation: ax equals b. Now, seeing that it's in the college section, you'd think that clearly there's got to be more to it, and you're right. In this equation, A is a matrix, and x and b are column matrices, or vectors by another name. I'm going to skip over the matrix and just talk about vectors here, which are essentially upgraded numbers. You can think of numbers in different dimensions. For example, a number line is just a 1D number. You can either go left, or you can go right, with a number telling you how far and the sign telling you the direction, which is what a vector is, a number that has magnitude and direction. So let's open it up to 2D and place a point. This point can be described with the x and y directions separately, or the direction and the magnitude. You can just keep going into whatever amount of dimensions you want. In this way, a vector can store more information in a number than a scalar, or just a regular boring number. Let's take a look at weapon stats. Suppose we take each stat as a separate dimension, which makes sense since they have nothing to do with each other, or in math speak, they're linearly independent. For every weapon, if we set up every number in a way that bigger and more positive is good, we can create a weapon number to tell us how good a weapon is. Accuracy and stability are easy enough since they max out at 100. I'm going to divide these by 100 to get them in a range between 0 and 1, so that all the stats somewhat match up. Concealment doesn't technically have a maximum, but the highest you can reach per weapon is 34, so we can just go with that. Threat does fuck all, so honestly we can just not have it. Reload time is better the shorter it is, so we can just inverse the reload. This makes it so that reload speeds closer to 1 second are better, and those which are slower are closer to 0. Conveniently, there are no weapons with a natural reload faster than a second, so that works out well. We can do something similar with rate of fire, which has no maximum. A higher rate of fire is better, so we can first convert to bullets per second, inverse it, and then subtract it from 1. This works out such that shooting 1 bullet per second will result in a dead 0, and higher rates of fire will result in 1. Note that this breaks for a handful of weapons which shoot even slower, but that's okay. We can just give them manual zeros. Now we're left with damage and ammo. Higher damage is of course better, but since heavy SWATs are the most important enemy in the game, let's just divide by 256, which is the head breakpoint, and cap every weapon that goes above this at 1 by hand. Ammo is tough. We want high everything, but there are no quick and dirty solutions here. For the most part, max ammo isn't super relevant, so let's just ignore it. Pickup is very important, so let's say that pickup is going to be the ratio of the magazine recovered. As for the magazine size itself, let's just say however many potential heavy SWATs you can kill in one magazine, and then invert that and subtract from 1. It's ugly, but whatever. So now we have a vector to describe weapon stats, and to get the magnitude, which we called the weapon number earlier, we just square every element, sum them, and then take the square root. There you go. Now you have an unusual way to compare what weapons are better than others. This method does have a few flaws, being that it only accepts base weapons without any skills or modifications, or any AoE effects. So let's fix, well, 2 of those 3, since AoE stuff is a rabbit hole on its own. Let's take, for example, the biggest and bestest suppressor. We can make a vector for the suppressor, and then add it to any weapon we want to put the suppressor on, assuming it's an allowed modification, of course. Vector addition is simple enough, just add straight across. Vector multiplication is not so simple, and we now need to go back to the matrices that I skipped earlier. Both vectors and matrices, and scalars, those plain old numbers, are tensors. Scalars are rank 0 tensors, or essentially a point. Vectors are rank 1 tensor, or essentially a line. Matrices are rank 2 tensors, which maybe you can guess, means they take up an area. The first rule of multiplication is that the dimensions have to match in a specific way. You can describe a tensor by its dimensions, like these weapon tensors are 1 by 8. Matrix multiplication is not commutative, meaning order matters. If we're multiplying first by this vector, then the next item has to be 8 by something. If we're multiplying second by this vector, then the first item has to be something by 1. Point is, these numbers need to match so that the end result has these dimensions. So back on topic, let's take something simple like fully loaded, which multiplies pickup by 1.75. All we need to do is construct a matrix that multiplies only pickup by 1.75. But how exactly can we do that? Matrix multiplication works by multiplying the elements of the columns and rows together and then summing them. So if we want to multiply a 1 by 3 and a 3 by 2, we get AD plus BE plus CF on top and AG plus BH plus CI on bottom in the resulting 1 by 2 matrix. Now, the matrix we're looking at here is a bit bigger, but it's a straightforward enough job. We can start from an identity matrix, which just has 1s going down the diagonal. This matrix is equivalent to adding 0 or multiplying by 1 in simple algebra. We just need to place the 1.75 times multiplier in the right place, and there we go, our fully loaded matrix. Just like you can add the biggest bestest suppressor to any weapon vector, we can multiply any weapon vector by the fully loaded matrix. You can make more and more complicated matrices to do whatever changes you could possibly want to any given vector, but it will get exponentially messier and longer the larger the matrix we need. Computers, however, fucking love these things. Compared to deriving or integrating or whatever else, just multiplying and adding a bunch of times is super duper easy. Matrices have their own list of special operations and whatnot, but they're not something I'm going to cover. Linear algebra is a bit more abstract than all the other stuff I've talked about, and that's because when you get into higher level math, it's a lot less calculating and a lot more theory. Let's get into the basics of abstract algebra, set theory. What is a set? A set is just an unordered list of stuff. Not very exciting, I know, but this is essentially the foundation of math. A simple example would be weapons. The set P of primary weapons contains every primary weapon. You can tell it's a set because I can talk to you about the weapons in any order, and there are no repeats within the set. And I don't mean that you can't have multiple of the same item in the set, it's just that the second copy would be ignored since it's already in the list. You can do quote-unquote math with sets, and they have their own operations. Let's take the set S of secondary weapons, for example. You can't add sets, but you can find their union. P union S is the set of every weapon in the game. You can't subtract sets, but you can find their intersection, and P intersection S is just the set of the saw, since you can equip the saw as primary or secondary. If you have the set M of all melee weapons, the union of these three sets is going to be every melee, primary, and secondary weapon in the game, and the intersection would be the empty set. The empty set is a kind of weird set. Why does it even matter to have a set with nothing in it? But it is important, and that's sort of how math works. From here on out, math just gets more abstract and more general, and harder to relate to Payday 2, so I'm just going to stop here. Oh wait, hold on. We've got one more from guest lecturer Rockimoto377 about topology. A topology is a set that satisfies some conditions, and a topological space is a set X paired with a topology T, sometimes written as XT. A notable example would be the real numbers with the standard topology, as in the set of all open intervals of real numbers. In a topological space, if a subset X is contained in the topology T, the subset, say U, is called open. To extend the idea of openness, topologists define this thing called a neighborhood. A neighborhood of a point is essentially a subset of our X, not necessarily open, called V, with a subset that is open, called U, that contains our point. A very useful example of a topological space is the metric topology, which uses the metric space. A metric space is a set X paired with a function d that tells you the distance between 2 points on the set X. A notable example is the real numbers using the distance function you know and love. A basis for a topology xt is a collection of open sets AI, such that for every open set in X, you can take a union of sets in our collection AI to equal it, and that if there is a point in 2 sets in the collection, there is a third, smaller set in the collection that contains our point. In the metric topology example mentioned, the natural basis that forms is the basis of n-dimensional spheres centered on an arbitrary point. If you visualize the definition, it's basically saying that given any blob on a 2D plane, there exists some smallest circle, or union of circles, that contains it. In Payday, if you think of the map as a metric space with the set X being 3D space and still using our old friendly Euclidean distance function, you can consider any ability with a range to be an element of some arbitrary basis of the metric topology in 3D space. I sure hope that made sense, and/or was accurate. I haven't taken a topology class, so I don't know much about topology aside from Donut Mug. Anyway, that's it for today. I hope you can see that math can be used in practical ways, and also for playing Payday, I guess. Join me next time where I teach you how to read. I know that's something Payday players also struggle with. And if you need me, I'll be in my office. Ah, come in. Welcome to my awesome office. Come closer. I want to talk about 2 things while you're here. First, some more math, because why not? And second, about this video and this channel going forward. Now, math is obviously very diverse, and I had difficulties with what I should and shouldn't include, especially with the more complex subjects. But right now, I just want to cover some stuff that I feel might have needed some more clarification, as I honestly don't want to go back and rework the sections. Here, I'll pull up Paint real quick. There are 2 things I should have clarified about division. The first is kind of trivial, the fact that dividing something by itself will net 1. I'm honestly expecting that everyone knows this, but it couldn't have hurt to clarify it for the sake of completion. The second is sort of moving into fractions, and it's that if you divide by a fraction, you can move stuff around the vinculum. Staying on fractions, I didn't explain any arithmetic involving them. Not how multiplying or dividing works straight across, not how adding or subtracting requires a common base, and not how exponentiation applies in general. I think the fact that taking a fraction to a negative power flips it is quite an important note, and if you're planning on explaining math to a child or something, explaining why that is would help boost their understanding. Speaking of exponents, I dropped a little note in the video, but it should have been something I explained explicitly. Taking something to the 0th power would make it 1, and taking something to the 1st power would make it itself. I think the 1st power is easy enough to understand, since you have 1 copy of a number, so the result is just that number. But the idea of having 0 copies of a number resulting in 1 is a bit more unintuitive. I think an easy way of explaining this is to show that it's an extension of repeated multiplication or division. 3 to the second power is 9, divide by 3 to get 3 to the first power, or just 3, and then divide by 3 again to get 1, or 3 to the 0th power. This also would have shown why 3 to the negative first power is a fraction where 3 is in the denominator, which I just mentioned, but didn't really explain why. I also didn't talk about roots, or fractional powers at all, which I think would have been nice. I think the fact that I didn't explain these too well is the biggest issue overall. With math, if you have a shoddy foundation, everything going forward will only be harder and harder to keep track of. I said a couple times in the video that this is something you need to accept because I'm not going to explain it, and while I think it was appropriate in those situations, it's generally a bad approach to math, especially at the lower level. The math that people interface with every day is something that I think should be understood at an extreme level, and it's because people just kind of accepted stuff instead of really learning it that I think so many people don't like math. But that's a widespread education system problem, not something for me to fix. Moving into middle school, I honestly don't even know how I made this mistake because it's so obvious, but it's the obvious ones that tend to slip through the cracks. I didn't explain coordinates at all. I just went right into functions and their graphical representations, which is how I think functions and their purposes can be understood best. But without explaining the coordinate plane, its axes, and how any of that works, the idea of a function on its own is kind of suspect. Again, at this level of math, I kind of expect everyone to know how a coordinate plane works, but another thing that I should have clarified. In the same section, I also said that in basic algebra, your inputs are usually just all numbers, with a small note that I'm referring to real numbers. However, I don't bring up other numbers at all for the rest of the video, so this real numbers seems very out of place. The most reasonable place to introduce differences between integers, rationals, and reals would have probably been in the elementary section, but it simultaneously seemed out of place. Finding Payday examples would have been easy enough for integers and rationals, but a nice way to differentiate the reals would be tough, especially without having introduced a bunch of other stuff. I don't really know how I could satisfactorily explain the difference between real and rational using Payday examples, and just going into math mode for it didn't feel interesting, so I just never covered it. That's of course also not mentioning complex numbers, which finding a Payday example for that would have been really forced. Or I could have tacked it onto the linear algebra section and just said, well, it's just another dimension, and moved on. But that also seemed wrong. When I started talking about areas, I feel like I just barely grazed on a satisfactory explanation of why you need lengths times more lengths. I vaguely mentioned that you can think about it as one length for every piece of width, which is just calculus in disguise, but I think the important takeaway that I didn't say out loud was depending on how many lengths you are multiplying, that is the dimension of the figure you're working with. Also in geometry, I could have explained more about trig functions. I vaguely explained how they relate to circles, triangles, and coordinates, but there's just so much more that I could have expanded on here. It just feels a bit half-baked, even though I think the idea I wanted to went across. I'm sure I could have put something together about the periodic nature of pub players going up and down. During the number 1 Dallas fan section, I explained that you can find the amount of teams without Dallas and then subtract them from the team's total to find the teams with Dallas. I think this is an intuitive approach, but I also should have explained it with a single calculation, being just finding teams with Dallas already on them. It's easy enough. Dallas is determined, so you're left with 2 slots and 21 characters, so you just do 21 choose 2. Obviously you get the same answer, and it's even a lot quicker and easier of a calculation, but I think it's not as obvious to piece together compared to what I presented. Now it's time to talk about calculus. Despite the fact that I said infinity is not a number, more on that later, a handful of times, I don't think I satisfactorily explained infinity. Infinity is very cool, but non-math people have basically countless misconceptions about it, and I would have loved to clear that up. Unfortunately, Payday doesn't exactly do infinity in an interesting way. The best way to understand infinity comes from limits, which is where the foundation of calculus is, but what exactly was I supposed to do to explain more about it? Suppose you drive a Longfellow away from a point. You get further and further and further and eventually fall off the map, but it's not like you're ever reaching infinity. Obviously you're going toward infinity, but never reaching it, but I think this doesn't really clear up anything. As much fun as it would have been to talk about infinity and various misconceptions, I think the only thing I could reasonably go over was that infinity isn't a number, and that it's used through a lens of limits to create calculus. And speaking of limits, I kinda sped way over them in favor of getting to derivation and integration faster, which, again, if you really want to understand calculus, you have to understand limits. It's not enough to just know some derivation rules and then some integration techniques to truly grasp what calculus is and how it works. Continuing with derivatives, I think I should have explained more clearly the whole rate of change is the slope is the derivative part. On rewatch, it feels thrown in because I just forgot about it earlier. Which I did. but I think my example of finding the derivative by the slope limit definition helps to disambiguate the whole slope rate of change derivative thing, even if I didn't explicitly explain it through the idea of a limit. I think it also would have been nice to show that the derivative at a point is the slope with a more extreme curve than the car acceleration, because that's also a handy way of understanding instantaneous rate of change. On the topic of integration, I gave the common area under a curve explanation, but honestly, I think this is a kind of unsatisfactory idea of integration. I didn't really explain why the derivative relates to the area, so using it for the integral is odd. If you consider that to find the area exactly, you take the height of a function and multiply by the infinitesimal to get a rectangle of sorts, where does the derivative come in? Imagine two rectangles with width z and heights y1 and y2. If you're trying to find the area, you could find the area of each rectangle and add them up, but you can also start from y1 and multiply by 2z, and then figure out what's going on up here. Well, the extra area can be found from the difference of their heights times the width of z. This difference of heights comes from the slope. Bigger difference, bigger slope, smaller difference, smaller slope. So to find the area, you need the slope, which is the derivative. If you add a third rectangle with a different slope, maybe it's a bit more clear. If there's a function governing the height of these rectangles, then the derivative will tell you the height differences rectangle to rectangle, and you can use that to find the extra area for each rectangle. Hopefully that makes sense. For differential equations, I should have been a bit more clear about how you find constants, especially with how easy it is to actually do. It simply requires some data. If I have this equation, which describes whatever, essentially I'm just trying to find which of these lines it actually relates to. To do that, I just put in a point. If I know that at 0 the answer is 5, I just put those in and solve for the constant. Sometimes you need to do a little more effort and set up a handful of equations involving derivatives, but finding the constants is always just about plugging in points. Also, in this section, I mentioned floor and ceiling functions in a note, but didn't explain anything else, which is an oopsie, because these are quite handy. Floor and ceiling functions basically just round a number. Floor rounds down and ceiling rounds up. Like if you have a kingpin injector, you'll get one every 30 seconds, but 15 seconds in, you don't have half an injector, you still have 0. You could say that your injector is the floor of time divided by 30, and this way, only after reaching 30 seconds will your function equal 1. These can be quite handy in real life, but I just didn't have anywhere nice to put them. In the statistics section, I broke down the binomial equation, but I should have given an example as well. If you're looking at something like 30 dodge and getting hit 3 of 5 times, well, first you have the idea of being hit 3 times and dodging twice, or 0.3 to the third power times 0.7 to the second power, and then the combination part will just take this and repeat it in every way to give you your result. I should have given more attention to sigma notation, because it's honestly just so cool, especially with infinite sums, and especially with converging infinite sums, but it wouldn't fit very well. Also in the chi-square section, I think I could have been a bit more clear on the interpretation of the p-value. Essentially, you have a null hypothesis, just saying that your experimental data is the same as the expected data. If the p-value is like 0.6, then it means that the odds that your data is the same as the expected data is 60%. Another interpretation is that you can expect that, changing nothing, 60% of the time you'll get the same result, or one that deviates from the expected even more. Yet another interpretation is that there's a 60% chance that your data turned out the way it did because of random chance. This is why you want a low p-value if you want to show that something actually has happened. If your p-value is 0.01, then it means the odds that your data and the expected data are statistically the same is 1%. Or, in the second interpretation, that only 1% of the time you would get this same result, or one that deviates further. Or, in the third interpretation, that the chance your result turned out like it did randomly is 1%. Admittedly, statistics is not my strong field, but this is how I like to understand the results of these tests. My only gripe with how I did the linear algebra section was with weapon number weighting. This was already the most heavily rewritten section, but if I were to rewrite it again, I would have changed how much each stat is valued. For example, if you have a gun that has 100 stability and does 16 damage, the magnitude of those two elements would be 1.002. If you take the exact same gun and give it 96 stability and 64 damage, the magnitude is then 0.992. So according to the weapon number, the first gun is better, but which of these would you rather use? The equation for the true value of each stat would have to be reworked to give anything useful. That covers everything I should have explained better, or should have added along the way. So now let's forget math and talk about other things. But first, let me launch up something more interesting to look at. Why did this video take so long? Well, believe it or not, I actually started working on this video basically immediately after finishing that last one. However, I was also going into the spring semester of my third year of college. I've always been a student who picks everything up fast and easy, and basically breezed through all school. It's kind of why I even started my channel. Well, that and a healthy dollop of depression. I had so much time lying around that I tried to learn everything I could about Payday 2, and then started helping others along their journey. But all of a sudden, my classes turned into serious business, and I actually had to start putting in time and effort. I wanted to work on this video over the summer, but I ended up getting a research internship and had to move away from home for a couple months. During those months, I got a lot of the audio work and asset collecting done, but not much of the video editing itself. When I got back, it was my senior year and classes still kept going hard on me. Now I've graduated with 2 degrees, one in math, and more notably, one in physics. Throughout all my life, I've never really known what I wanted to do. It was only in college that I realized that I really liked physics. Soon after uploading this video, I'll be off to grad school for physics, and ideally we'll spend 40 to 50 years doing physics. Considering the jump in effort I've had to put in, I can't confidently say that I'm going to have the free time to continue making videos. Well, sort of. During my break from video making, I've thought a couple times about what I actually want to upload. Videos aren't just something I spit out. I like to think of them as an expression of myself in a way, and I concluded that for the Carrot channel, I want to have 2 requirements for a video. It must be unique, and it must be high effort. My best videos are those which I worked hard on, and those which I think no one else had already made, or could really make. So could I go back to making a Payday 2 build every now and then? Yes, easily. Despite the fact that people say that Payday is officially dead, it just isn't. Yes, Payday 3 is still unplayable dog shit, and a lot of the content creators left, but this game still does numbers. I mean, I still get like 50,000 views a month, and that's without uploading a video in a year and a half, and over 2 years since a Payday 2 video. It would be so easy for me to make a quirky build and upload it every 2 weeks like I did with bi-weekly builds. Genuinely, pulling back the curtain, those videos took me less than 3 hours to conceive, script, record, and edit, sometimes a bit longer if pubs were dead. But do I want to do that again? Not really. It's effectively slop that literally anyone with a decent understanding of death sentence could make. Seriously, if you want to try making videos, build videos are so easy to make. Join some Discord servers and advertise, or ask for advice. Believe it or not, the death sentence community is quite pleasant if you look beyond the surface. They're just very passionate and always seeking content that isn't just a solo of a map or another anarchist Yzma build. Builds may not be the most exciting type of video to make, but I think it's great to get your bearings with an editing software of choice and start interfacing with the community in a new way. I picked up a copy of Vegas 18 from Humble Bundle for like 20 bucks, and you can pick it up for free if you have some know-how. Anyway, back on topic. This video is one that I put a lot of time into, and nobody else could have or would have made it, so I'm quite proud of it. With my standard of videos having to be unique and high effort, I honestly don't think I want to upload to this channel anymore. Ideally, I would delete all the stuff clogging up my channel that I think is bad content, but I'm not going to delete anything as I'm a fan of archiving. I've still got ideas for stuff I would like to make, but I can't promise that I'll have the time to invest into realizing those videos. And even if I did, well, I've got other things that I want to do. I want to see if I can learn another language or another instrument, and my bookshelf is only half read. As such, I'm satisfied with finishing the Carrot channel here. That's not to say you can't get more of me if you want. I have a second channel after all, where the effort requirement is not something I care about. I upload random shit there, from tea reviews and cooking guides, to slop tier lists and shitposts, to physics and gameplay, even with some Payday 2 sprinkled in. In the future, I plan to use Carrot 2 to realize those video ideas that I can't commit to making on Carrot, but that's also kind of up in the air depending on if I feel like it. Anyway, a few more things I want to get out before I wrap up the Carrot project. Periodically, I've had people ask me if they can translate a video of mine into a different language or add subtitles or something, and my solution has always just been to send them the script to whatever video they were interested in. Obviously, I'm a big proponent of spreading information, and so in the description of this video, there's a Google Drive folder with every script that I could find for my videos. Feel free to do whatever you want with them. Use them for ideas, translate them and make your own videos. Hell, just dub over my videos if you want to. I'm not going to copyright strike you. Just note that sometimes I change the wording of something after saying it out loud while recording, so the scripts aren't always 100% accurate. You may have noticed me re-recording some parts of this video. Sometimes I just want to add something in, or change it later on. Sometimes you'll see notes to myself in the scripts as well, and of course some of the older ones may have some outdated info, or just be wrong, so use your brain. Well, I guess it's time to close the curtains. I want to say thank you to a couple people. Those who helped me with the dodge data, Ter for recording the movement-related stuff, Rocky for the topology segment, and Stalin for the original idea of this video, however long ago that was. He initially suggested an April Fool's math video, but I took it a step further, you can say. A more general thank you goes out to everyone watching. It was everyone watching that made me want to improve the videos and dive even deeper into the game. Also, it's worth throwing out a general thank you to the death sentence community. I enjoyed watching those videos years ago, and I'm happy that you enjoyed watching mine. I want to thank everyone who I've met and enjoyed spending time with in the greater Payday community, whether I met you a week ago mingling in my Discord, or I met you before a Kimbo Krinkov demonstration was even uploaded. Thank you, and I won't see you next time.